So let's start the flange by going to surface, multi-surface draft. I'll just turn off my criteria for now. And we have the defaults here, and I have a draft built. Well, I'll just reset to be sure it's at the defaults for you. And then we'll go to draft surfaces. By default now, a new option is radial, but I want to explain what that is because you don't necessarily want to use it every single time you build a draft surface, but I'd like to explain what it is. So first, let's build it with just your typical construction technique, I guess. I want to build it to those edges. I have a vector that I'd like to use, so I select picked and select a vector. I'm going to ask for 5 degrees from our criteria and 15 long and build that. Now I'll look to it in the left view. I've created, we have a vector and I created a plane on that vector so that I have a die view. And if I'm in this die view and I cannot see the flange, it means it's closed or not open to draft. So I'm going to switch this to a negative. Okay, and there we go. So let's just analyze that really quick. We needed a 15 millimeter flange, and that, if we turn it back on, that flange was 15 millimeters to an offset. It wasn't measured along this angle. It was a 15 millimeter offset of this surface to trim that off. Okay, that can be the case sometimes. Other times it could be length of flange. So right now, if we analyze how this was constructed, evaluate the deviation between curve and curve, 14.39, 14, 14.7, a bit strange. That should be 15. And then as we get over here, if we measure that same distance, we get some values around 7.8 to 8. Why is that flange not 15 millimeters long? That's how long it needs to be, but it needs to be that on an offset of this surface. So really specifying 15, it's 15 to an offset surface is what we're doing. So where's the 15 coming from right now? If we measure the distance, okay, so just 2 points, and we measure from the end of flange to the start of flange, that's 15. So those lines are created in the direction of this die view. That's the distance that's being measured and calculated. So we need to switch that up. Delete my locators. And what we also had here included was some base surface data for the outer lens. And I know that we had specified a 15 millimeter offset of that surface. So if I turn this lens base off and we measure the distance surface to surface between here and here, we get 15 and so forth. So I want this flange to be built to this surface. I don't care about how long it is from point to point. Delete locators. And by the way, that doesn't have to be an offset. It can be any surface you can build the flange to. So how you get the software to build the flange to a surface is by selecting the to surface option. We accept the original curves, and now we simply select our surface data. So pick our surfaces to match. It's not letting us pick this guy. There it goes. And update. Okay, so now that surface is being built so that it touches a 15 millimeter offset. I'll just turn on my hardware shading here. So now that surface is built, its length varies along this edge depending on how far it has to go to get down to a 15 millimeter offset surface. Okay. But now when I look at something, I'll delete my locators. And we have a lot of skewing in here now. So by skewing, we've talked previously about this acute and obtuse angles being problems when we run a fillet across here. Well, the reason why this is so acute is that the orientation of this line is based on planes of this vector. So all of those are parallel. Every control vertex in this surface is on a parallel plane to that. one thing that can happen is you get a lot of extra surfaces. So if we put a surface fillet between here and here, and we just say 2.5, and we do default here, we get 3 surfaces. And if we do an edge align on this interior, you get a really skewed set of control vertices right there, right? With this acute and obtuse angle. So I'm going to undo that and show you a new option. And also, since there's nothing to project this length onto, the software stops building at that point. So we could untrim this and extend it and get a further build, but I'm going to select the radial option. And what the radial option does is it builds all of these control vertices structures on radial planes to this theoretical intersection. What's a radial plane? A plane that is perpendicular to this line. So in essence, if we create a plane, we'll do it based on geometry. If we pick this edge right here and we create a plane and we make it this plane, that plane right there all the way along here is radial. Okay, that's a radial plane, or a plane that's perpendicular. So right now all these hulls are following that structure of this surface. Okay, so as we get over here, all of these are now constructed in a nice radial manner. An easier way to look at this might be to go into the top view. I'll turn off my construction and my length. I'll go into the top view, and you can see how radial, 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 and they're fanning out. If I switch that up and we say don't be radial, they'll all point in this direction. So you can see how they're all skewed now. Same length, but now they're all skewed. Okay, so the radial option is really nice. Go back to our die view and check in this view, and we can see that it's still in fact open. Okay, so we've got a little angle here. So this is where we want to get in and maybe do some diagnostics and check that. So first thing I'm going to do is fix it. So I know that I need to move a CV, and I'm going to move a CV on this surface, and let's just move him and all of his friends normal. And I'm just going to fix that angle. Okay, that was very slight movement right there. So now what I need to do is check my surface angle and be sure that I'm open to the correct draft requirements. That requires me to get my surface orientation set correctly. So I'll just go to set surface orientation, pick those. Now they're all pointed at me. Now let's go into our diagnostic shading. All right, and I'm going to hit surface evaluate. The evaluation I want to run is a draft angle check. Okay, turn that on. I'm going to pick the vector, go down here and say I want to use update from selection, that vector, and I would like to have positive draft of 5 degrees, and it says I'm totally closed everywhere. How about a negative draft of 5 degrees? Okay, if you remember when we built it, we had to use a negative value. So this is a negative draft. So if we now look at this and we query edit and put right here, we have a draft angle of 5.0. If we move around, you can see 4.98, 4.97. So an option in here is a negative tolerance. So if we wanted to see everything that was in 0.05 degrees, or maybe 0.1 of a degree, so all of the area right now in red is within 4.9 degrees of being open. And in this little local area down here, 4.8 or 4.7. We could tweak a couple of CVs and bring that home. Okay. Now, one thing that I notice over here, and I'd like to go back and recreate this, is, well, there's 2 ways to do it. One, I could simply say edit, trim convert, and trim convert this surface and this surface. Okay, they don't seem to be working. Edit, let's untrim them. Edit, trim convert, you to here. It works. You to here. Doesn't like that. I'm not sure why. So I'm going to turn extend on and selected, And I'm just going to try to extend each end of this a little bit. It thinks it's extended, so it won't let me do it. Okay, so all of this rigmarole right now that we're trying to do here by getting this trimmed back so we have a nice surface structure that we want to use, I want to show an additional option in here. So rather than going through all this rigmarole, what I could have done originally, select my edges, pick my vector, grab my flange surfaces for length. I've got 5 degrees still in and radial. Okay, if I turn my control vertices on, it still creates this type of intersection. I'm going to turn that intersect flanges to trim convert, and it will trim convert those for me automatically, so I don't have to go and do that work. Okay, so close that, turn my construction layer off, turn my flange length off, Alt-O. Actually, I need my construction layer so I can pick my vector. I'll ask for curvature analysis and pick a vector, update from selection, and everything is red. Failing. Any guesses? You always have to check the orientation of your surface data when you're checking for draft, okay? So all of that now is fixed, and when we pick nothing, now everything is green. We've got a little bit of yellow, some red. What we could do over here, grab these two surfaces, turn their control vertices on, and this is what's nice about these control vertices being trim converted for us. I can move both of those control vertices along this vector and get that to be green. Come over to this end. Okay, I'm going to turn just both of these surface CV sets on. I'm going to go to project and move this to here. Now I see that I have a problem. I'm going to go to this little normal, move those CVs in a little bit, let them taper a little bit. Let's go normal. Take one away. Now just grab a single and his friend. And there. Now we're 5 plus or minus a tiny bit. To check the plus or minus a tiny bit, you can query edit and right mouse button, and it will tell you right here the exact number you are anywhere on the surface. Okay. So if we want to know, okay, how far is it off right here in the corner, Mr. Engineer? It's 0.03 degrees off. I think he could live with that. Okay. So that's an explanation of some of the new flange tools. And now in the next video, we're going to start doing some offsetting and underflushing to continue on this lamp.